Hi friends, in this video we are going to talk about the signal design by Webster's method. So first of all, remember this name. The IRC, Indian Road Congress, is suggesting Webster's method for the signal design. So that itself can be a direct 1-mark question. Now, in your day-to-day life, you might have already seen so many signalized intersections, right? These slides are very familiar to you, right? So we are having the green signal, then amber signal, then red signal, right? So this center one, in general sense, we call it as a yellow type or yellow light also, right? So technically this is not yellow, this is amber, right? Now in which order they used to show this signal, that order also can be asked for the exam for 1 mark. Suppose if you are seeing green signal first, then after this it will be amber, then it will be red. So the order will be always like this from bottom to top. After the red again you will be getting green, amber, red, green, amber, red, like that, like that. It's going to be a cyclic process. Right. So if I'm just representing the time of all these signals, say suppose somewhat like this, just I'm taking some example, okay? So let's say the green or red time is around 30 seconds. Simply one example, okay? Then green time is 40 seconds. Then amber is around 2 seconds. Then again, after this amber, again, what we are going to get? The next red. Let it be that is 30 seconds. After red, again, I'm going to get green. Let it be around 40 seconds. Again, 2, again 30, again 40. Like that, it will be going now. So this is the order in which we are getting the signal. So there is no particular starting point here, no? From anywhere, suppose from the starting of a red signal to the starting of the next red signal. If you're taking, what will be the duration? 30 plus 40 plus 2, 72 you are going to get now. So that time I can call as the cycle time or cycle length. Both are same. So length means, don't misunderstand that it is in centimeter, meter, like that. Here length only means the duration. So according to our example, it is 72 seconds. But suppose if you are taking it from one green signal to the next green signal, then how much you are going to get? And then also 72, 42 plus 3, sorry, 30. That is also 72. Similarly, if you are taking the duration from starting of an amber to the next amber, see somewhat like this, then also you are going to get the same duration, right? So from any point to the same point again in the next cycle, you are going to get the exact same duration. That is called as cycle time. So just for the sake of making a definition, what we generally define as a cycle length is, it is the duration from one particular red signal, beginning of a red signal, to the beginning of the next red signal. What is the meaning of that? What I told you is, so how we are defining a signal cycle. See, from the starting of a red signal to the starting of the next red signal. See what I have marked right now. This is what? Starting of a red signal to the starting or beginning of the next red signal. This is actually what we define as a signal cycle. Understood? The duration of a signal cycle is nothing but cycle time. So this definition is also important. From where to where we are defining starting of a red signal, not the end of a red signal. Okay. Starting or beginning of a red signal to the starting of the next red signal is defined as a signal cycle. And the duration of that signal cycle is nothing but cycle length. So don't think that always it will be 72. I have just kept an example. That's it. Okay. And what should be the duration of this cycle length? What is the best duration? You see, suppose if I'm just taking a curve like this or a plot, a graph like this, where average delay per vehicle I'm putting on y-axis and cycle time or cycle length I'm putting on x-axis. Now, what we have understood in surveying, or what I can say, the traffic study, whenever the cycle time is very less, say some 5 seconds, 10 seconds, 15 seconds, like that, very less time, then the delay will be too much. It will be very high. And as you keep on increases the cycle time, like 20, 25, like that, you keep on increases, what we have understood is the average delay per vehicle keep on decreases. Keep on decreases like this. But whenever you reach at some certain value of cycle length or cycle time, what we understood is it again starts increasing like this, which means for a very high value like 100 seconds or 120, 140, like we don't know how much it is. If it is too much, like 200, 220 like that, then it will be too much high. See, I'm simply putting some values. There is no standard value like this. Now, here actually what we are getting, an optimum point we are getting now. Okay, so what is the importance of this particular point? Here we are getting the least value in the y-axis. So what is the value in the y-axis? The average delay per vehicle. Suppose if this is some particular value, some x. What is that x? This is the least average delay per vehicle, right? Or otherwise I can say corresponding to this particular time. Here x-axis also will be getting a time now. I'm just keeping it as cycle time C. O stands for optimum. So this is nothing but optimum cycle time or optimum cycle length. So how can we define optimum cycle time or optimum cycle length? This itself is a very important question which is asked for many competitive exams. So optimum cycle time means it is a cycle time at which the average delay per vehicle is the least or minimum. Understood? That's how we define the optimum cycle time. See, similarly, you used to study in soil mechanics and all, right? Like if you are taking the dry density on y-axis, water content on x-axis, we'll be getting a graph somewhat like this, you know, increasing and decreasing. And wherever you are having the maximum dry density or bulk density also you can take. Okay, that value we generally call as optimum water content or optimum moisture content. So this word you might have already heard, right? Optimum. So there it was corresponding to maximum value. Here it is corresponding to minimum or least value. That is the only change. Here also we are using the same word optimum. Okay, so this O stands for optimum. So CO is what we are going to calculate. So this is very important, no? Because maybe if this value is around some example I'm telling, let it be this is 70 seconds. So which means in the signal, if you are a traffic engineer and you are giving a value which is less than 70, then what will happen? Obviously, the delay will be increasing. And if you are giving a time which is greater than 70, then also delay will be increasing, right? So what is the best thing? The best thing is to provide this exact value of CO, optimum value, so that the least will be the average delay per vehicle. This is, no, it is a delay thing. No, delay we need to reduce always, right? So that vehicles can move faster. So this is what is important for us in the signal design and how to calculate this optimum cycle time. So that is why a person came forward whose name is Webster, and Webster has given us an equation to calculate the optimum cycle time. And that equation is like this: optimum cycle time CO is equal to 1.5 L plus 5 whole divided by 1 minus capital Y. So this equation is very important. It's a direct empirical equation. We need to by heart it. There is no other choice. Now look at here. There are two unknowns in this equation. One is capital L and the other one is capital Y. And there are two other coefficients. Initially it is 1.5, one coefficient. Then it is 5, second coefficient. Then there is obviously there is a 1 minus thing also. So 1.5 will be always constant there. 5 is also always constant there. 1 is also always constant. The value which is changing in the question will be this L and this capital Y. So we need to find how much is capital Y and how much is L, and we need to substitute in this equation. These two are the unknowns. So that we should know what is the meaning of this L and what is the meaning of capital Y. Understood? So that's what we are going to see now. Whatever you are getting here, that will be in seconds. Seconds means what? The duration of one cycle means it will be the red signal plus green signal plus amber signal. So the duration of all these three is nothing but we are getting here in seconds. Understood? Together, cycle time it is. Now let's understand what is the meaning of L and Y. That I'll be telling you using the help of a question. Look at this question. It's a previous gate question. The question is like this. In a signal design, if the sum of ratios of normal flows to saturation flow, which means what? Sum of ratios of normal flow to saturation flow means normal flow by saturation flow. That's what they are telling now. But it's not simply the ratio, it is the sum of. Sum of means what? We have to keep on add it, which means similarly we'll be having some other ratios also. If I'm just calling it as some small y, let me this is y1. So similar to this y1, I'll be having one more ratio, which is also another normal flow by another saturation flow. Okay, so like this, so many ratios I will be having. So suppose this normal flow is somewhat Q1, then this may be S1, and this normal flow will be completely different from the first normal flow. I can keep it as some Q2. This is somewhat S2. So this saturation flow and this saturation flow are different. Okay, so similarly, we are having multiple small y values, these ratios. Okay, so this ratio generally we call as critical flow ratio. You know why we are calling it as critical flow ratio? Because this normal flow is also called as critical flow. Okay, so I can say critical flow ratio is nothing but the ratio of critical flow to saturation flow. Like this, so many critical flows I can calculate. Now I'm going to add all the critical flows I'm having, critical flow ratios I'm having. Okay, which means critical flow ratio y1, critical flow ratio y2, critical flow ratio y3, like this. How many critical flow ratios I'm having? All those things I'm going to add. And that is nothing but your capital Y in the equation. Understood? So look at here now. Sum of, right? We are adding sum of ratios of normal flows to saturation flow. Yes, what is that? That is nothing but your capital Y. Understood? That is given in the question as 0.5. Now, how to calculate this normal flow, saturation flow, everything I'm going to tell you. Don't worry, okay? This is only the first question. Now, the total lost time per cycle is also given, no? The total lost time per cycle. Understood? This is nothing but your capital M. So, this is nothing but capital Y, and this is nothing but capital M. So, this is how it is defined. So, what you can do, these definitions, you can write in the or along with the equation also. So, what is this L? L is nothing but the lost time per cycle. Lost time per cycle, and this is sum of, I can just keep it as sigma of all the normal flows to the saturation flow. Understood? That's it. So how many normal flows and saturation flows will be having? Every time a signal will be designated like a two-phase signal. Have you heard about this? Two-phase signal, three-phase signal, like that you will be seeing in the question. No? Three-phase signal, four-phase signal, like that. There is no one-phase signal, okay? One-phase signal is not there. At least it will be two-phase signal. So two-phase signal means like this. Suppose, can I call it as like Y also? No, this normal flow to saturation flow is Y. For a two-phase signal, two critical flows will be having. Then it is going to be Y1 plus Y2, capital Y. No. For three-phase signal, we will be having three ratios, Y1, Y2, Y3. Similarly, suppose if you are having a four-phase signal, that will be given in the question, okay? Whether the signal is two-phase, three-phase, four-phase, that they will mention in the question. Then four ratios we will be having. So we need to add all those four to get capital Y and to substitute here. Understood? So these things will be mentioned in the question, whether it is two or three or four phase like that. Got it? Now, if you are solving the first question, one by one, we can proceed the level of the question. So what they have mentioned here, the lost time per cycle is capital Y. The lost time per cycle is 10 seconds. And the sum of ratios of normal flow to saturation flow is 0.5. So if you are substituting in our equation, C naught is equal to 1.5 into 10, right? 1.5 L plus 5 divided by 1 minus, how much is capital Y? That they have given 0.5. Okay, that's it. It was calculated. you will be getting exactly 40 seconds as the answer. Right or not? So option D will be the final answer here. Got it? Now, just we are moving forward to somewhat higher question. Look at here. Here they have, instead of giving the sum, they have given the ratios of approach flow to saturation flow. Approach flow is nothing but our normal flow or critical flow. So you got another synonym, right? Normal flow, critical flow, or approach flow. All these three are same. Got it? So similarly, this saturation flow you can call as departure flow also. Departure flow. Okay, or departure rate. This normal flow we can also call as arrival rate. Somewhere if you are seeing arrival rate and departure rate, arrival rate is nothing but normal flow, departure rate is nothing but saturation flow. Okay, these synonyms also you can keep in mind. Okay, now instead of giving capital Y directly, in the previous question they have directly given like this, no? But now what they are telling is that there is a signal which operates in two phases. Have you noticed that? In two phases means what? We'll be having two ratios. We'll be having two critical flow ratios like this. That is what they have given in the question as 0.37 and 0.4, right? So we are going to get here as 0.77 will be the capital Y value, right? Previously they have directly given. Now they have splitted it. That's all. Okay. Now capital L, what is that? Lost time per cycle. They have given as 3 seconds. Right or not? Here is the point. This is wrong. Why this is wrong? Properly notice it. What they have given is the lost time is 3 seconds per phase. Have you seen this? Per phase, not per cycle. What was L? L was the lost time per cycle. So in this cycle, how many phases are there? Two phases are there. Right? It's a two-phase signal, which means for the first phase, we are having 3 seconds lost time. And for the second phase, again, we'll be having a 3-second lost time. Then totally in the cycle, we'll be having 6 seconds lost time. Understood? So capital L is going to be 6 seconds. Then how much will be optimal cycle time? 1.5 into 6 plus 5 divided by 1 minus 0.77. Understood? So once you are calculating it, you are going to get around 60.87 seconds. Understood, guys? That's it. This is how we are going to calculate. This is itself again a gate question. Okay, so this is how you need to do it. Now, always they will mention what is the or how much is the number of phases that they will mention. Suppose if you are getting a confusion, what is the meaning of this phase? I'm telling you what is the meaning of phase. Okay, so look at an intersection like this. Just think about it. You are standing in the queue. Maybe a red signal is there and you are standing in the queue. Now, how many set of movements should be completed so that you will also be getting a chance to move? Or how many set of movements will be happening here? Look at here. I'm just representing it like this. These are the 4 stages which are going to happen. So first of all, when vehicles are moving from this left to right, obviously vehicles coming here, they will be standing here because here it will be a red signal. And here also so many vehicles will be standing. Here also red signal. Okay, similarly here also red signal. So these directions will be stopped. And only vehicles coming from this direction will move. So this is the stage 1 or phase 1. This is what I have written here, P1. After some time, they will be getting the red signal. These vehicles will stop there. And some other plane will start move. So this is the second stage or phase 2. So phase 2 means second stage. After some time, another road will start move. Now these vehicles will move. And in all other places, they will be having the red signal. So this is what is going to happen. So previously, here it will be a red signal. Here and also here it will be a red signal. And after some time, here again it is red signal. Here also red signal. Here also red signal. Vehicles will be moving like this. So in 3 and 4th stage, 3rd and 4th stage, everyone will be getting a chance to move. And after this 4th one, again it will be the first one. Again they will be moving. So in 4 stages, we have completed all the movements, right? So we can call it as 4 phase also. So it's a signal cycle or it's a junction which is operating in 4 stages or 4 phases. Understood, guys? So how can we define a phase? Phase in a signal design can be defined as the number of stages in which all vehicles or roads will get opportunity to cross the intersection, or we can say opportunity to move in the intersection. Otherwise, they need to stop. No, that's what. Got it now? That's it. Okay. Now, if you are going into the next question, let's see. I'm just slowly, I'm increasing the quality of the question. Now, previously, we have seen there were 2 phases, no? Now, I don't have to explain this question, I guess. Can you please solve it? Can you please pause the video and solve it first? Pause the video and solve it. There are 3 phases, right? That is why they have given 3 critical ratios, right? So 3 phases means capital Y is going to be Y1 plus, Y2 plus, Y3. Here also they have not given what is the sum. Instead, they have given what are these ratios. First one is 0.3. Second one is also 0.3. The third one is 0.2. Now, if you are adding, you are going to get 0.8 as the capital Y value. Right or not? Now, C0 is equal to 1.5 into how much is capital L? Look at the question. What they have given. The lost time per phase is 3 seconds. Right? I already told you that. Then how much will be capital L? In the first phase, it is 3 seconds. Second phase also 3 seconds. Third phase also 3 seconds. By default, we'll assume all are same. So total it is 3 seconds. Sorry, 9 seconds. Sometimes they can give you different values also. Like first phase, it is 3 seconds. Second phase, it is 4 seconds. Third phase, it is again 3 seconds. Like that, if they are giving, then it's going to be 10 seconds like that. But by default, if they are not mentioning anything like that, we'll assume all the lost times are same like this. Okay, so directly you can take 3 seconds into the number of phases 3, which means 9 seconds will be L value. Got it, guys? So 1.5 into 9. So this is what you need to first. Then 5 divided by 1 minus 0.8. So just solve it. Let me solve it also. 1.5 into 9 plus 5 divided by 0.2 will be getting. So 92.5 will be the answer. That's it. Understood? Understood? So always check what is the number of phases. See, suppose if they are not mentioning this, okay, they are simply telling that, see, like this. A signal is designed like that. They have not mentioned the number of phases. But then also we'll understand that it's going to be 3 phases. How? Look at here. What I told you. How many ratios we are going to have? Whatever be the number of lanes. Sorry, whatever be the number of phases. That many small y values we are going to get. So in the question, if they are mentioning that there are 3 critical flow ratios, which means there will be 3 phases also. That's why we are getting 3. And if they are giving only two critical ratios, which means it will be a 2-phase signal. If they are giving 4 values of small y, then we can understand it's a 4-phase signal like that. Understood? That's it. Now suppose we have already seen this kind of question. Now, so either they will be giving directly per cycle, as in the first question we have seen. Here they have given the optimum cycle time, sorry, the lost time per cycle directly. If they are giving per cycle, then again don't multiply, okay? Okay, so if it is a 2-phase signal and they're telling that it is a per cycle is 10 seconds, then don't multiply. Got it? So properly read the question, okay? If it is per cycle, directly use it. If it is per phase, then multiply with the number of phases, then use that bigger value. Okay, now there can be another twist. What is that twist? I'm going to show you in this question. Okay, so before mentioning that twist, let's calculate small y values. See, till now what we have seen, they have already given small y values. No, the ratios they have already given. Here, suppose if they are giving the values like this, and we need to calculate the small y value. Okay, so how much it will be? The first one will be 600 divided by 3000, right? It's going to be 0.2, right? 0.2. Let me just confirm it. 600 by 3000. Yes, 0.2. Similarly, the second one is going to be how much it is? 700 by 2800. That's going to be 0.25. 1 by 4. Now this is 720 by 3600. Again, this also is going to be 0.2. Right. So these values are what we mean by small y's. Right. Now if I'm adding all these three values, I'm going to get capital Y. How it is going to be 0.65. And this value is what we require in the calculation. Okay. So if I'm substituting 1.5 into how much is L? L, I don't know. They have not given L, but they have given something else, no? All at a time 6 seconds. So can you just take, it's a 3 phase, no? So can I take L is equal to 3 into 6 seconds equal to 18 seconds? Can I tell like that? Absolutely wrong, right? Why? This given 6 seconds is not lost time. It is what? It is the ordered time. What is this ordered time? We have discussed only lost time, no? So this ordered time is the tool to calculate lost time. Okay. Now, if they are giving ordered time, as per IRC, there is a recommendation. What is that? The lost time per cycle capital L is equal to 2n plus R. This is a suggestion or recommendation by IRC. So this itself, the calculation L can be a question. Okay, maybe for 1 mark they will ask. Now in this equation, what is R? This R is what we are seeing in the question, ordered time, that they will give in the question. How much is ordered time? So please don't get confusion. This ordered time is not this ordered time. Initially we have seen 30 seconds. This is not ordered time. This is what? This is simply read time. That's it. Ordered time is different. This is read time. Ordered time means sometimes in signals you might have seen everywhere. So here, everywhere there will be a red signal. Why? No vehicles should move. All vehicles should stop there. This is what is called as all are red. Na? This is called as all red time. It will be like 6 seconds, 10 seconds, like a small value. Why we are giving that? You have seen, na? So many passengers are crossing. That is why. So for pedestrian crossing, what we'll do? Sometimes we'll be giving the red signal to all the lanes. See, suppose here if you are taking normal case, only 3 roads are having red, no? 1 road is having green signal. In all the phases, at least 1 road is getting green signal. Only other lanes or other signal vehicles are getting red signal. What we are telling now is all are getting red signal, which means no one can move like that. So such a situation is actually called as all red time. Understood? Now, if they are mentioning in that question, definitely they will be giving that value in the question. We can use this equation 2n plus r. This one more unknown is there now, that is n. That n is nothing but the number of phases. Okay, what is this number of phases? Already we have seen 3-phase signal, 2-phase signal, like that. Understood? This is how we need to calculate here. Which means in this question they have mentioned that it is a 3-phase signal, which means our n value is 3. And ordered time is also given as 6 seconds. Then in this context, how much is going to be L then? 2 into, it's a 3-phase signal, so into 2 into 3 plus ordered time is 6 seconds. So it's going to be 6 plus 6, 12 seconds. Understood? So we are going to substitute 1.5 into 12, right? Plus 5 divided by 1 minus 0.65. This is nothing but your optimum cycle time. Understood? So just calculate it. You are going to get 65.71 seconds. Okay, so let me just calculate and just confirm it. 1.5 into 12 plus 5 divided by 0.35 we will be getting now. So yes, it's going to be 65.71 seconds. Understood, guys? Now, can I ask you an extra question? Extra question. What is that extra question? What will be the lost time per phase? We don't require here. Okay, this is something we don't require in this question. Simply I'm asking just to develop concern. We know lost time per cycle is how much? 12 seconds. This we got. Then how much will be lost time per phase? There will be 3 phases now, right? So for each phase, it will be how much then? 4 seconds. Understood? 4 seconds, 4 seconds, 4 seconds. Like this only we will be getting 12 seconds, no? Okay. So either they can give the data like this as we are seeing in the question, or suppose if they were giving like this, the lost time per phase is 4 seconds. Then also what we can do, 4 seconds into 3, then 12 seconds, like that also we can take. So depends upon the question, how they are giving the data. Sometimes we'll directly multiply like this and take, or if they are giving all at a time, then use this particular equation 2n plus r and calculate n value. Understood, guys? So I hope now you have got enough idea regarding how to calculate the optimum cycle time. Okay, so sometimes in the question they may not be using this word optimum. Still they will be asking what is the cycle time. Okay, so in such a context you understand they are actually asking you the optimum only. Even if you are not seeing this word optimum, we don't have any other equation to calculate it. Calculate optimum cycle time only. Understood? Now I am moving forward. Another concept also I am just trying to incorporate here. The same data it is. Okay. But instead of optimum cycle time, here in this question, what they have asked is the effective green time. Right? Same data. What they are asking is different. Now, first of all, understand how to calculate this effective green time. This is also given by Webster only. So either they can ask you the optimum cycle time, or they will ask you of effective green time. So this effective green time does not mean that it is this. According to our example, this is what? This is the actual green time, not effective green time. Okay, don't get confusion. This is the actual green time. What we are going to calculate now is the effective green time. Now, what is the meaning of effective green time? It is actually the time during which vehicles were in motion. If vehicles were moving, then that duration is called as effective green time. Which means what? The green time. In the green time, definitely vehicles will be moving. Obviously, all this time, vehicles will be moving. What about the amber? In amber also, vehicles will be moving. No? They will be slowing down and trying to stop. Right? So sometimes during the amber, vehicles will be accelerating also. The vehicles which are already reached at the intersection, they will be accelerating now and they will try to cross the intersection. So however, during the amber time also, the vehicle will be in motion, deceleration or acceleration, whatever it is. Only during the red time, it will be under rest. Okay. So if I am adding this green time, 40 seconds, plus this 2 seconds, what I am going to get? 40 seconds plus 2 seconds, I'm going to get 42 seconds now. So this 42 seconds is actually called as effective green. But sometimes what may happen, even at the starting of the green signal, the vehicles may not be able to start. Some starting trouble may happen, or the vehicle which is standing in the queue, he may not be starting the vehicle initially. He may be losing some time. Right? He may be looking here and there. Some advertisement board may be there. He may be looking there, or he may not be noticing that the signal has turned to green signal. Okay, so which means initially some time he may be losing, right? So for example, some 1 second or some 3 seconds he is losing. He's not noticing the green signal. So in this 3 seconds he is actually not moving, no? So suppose like this, if any delay or time wastage has happened in this duration, for example, some 3 seconds time wastage has happened. Then in this 3 seconds, he has not traveled, no? Vehicles is not in motion, no? Then what to do? From this 42, we need to minus that 3 seconds. Then 39 seconds you will be getting. Understood? That's how we need to calculate the lost time. I hope you got the point. What I told you? Suppose initially in the green time, if you are losing some time, okay, then vehicles will not be in motion, no? Suppose if it is some 1.5 seconds, another example, then how much will be effective green then? From the entire green plus amber, you have to minus this particular lost time, initial lost time. Now the remaining portion only will be the effective green time. That's what I told you. Got it? Now, if they are giving the data like this, we can calculate it like that. Otherwise, Webster has given us a direct equation also to calculate effective green time. Generally, in the gate examination, they used to ask like that only. Maybe in state PSCs, they can give you the data like this, some diagram and all, and they can ask you what is the effective green time. But generally, in the gate examination, they used to ask the question based on direct equation given by Webster. Now, what is that equation? It is C naught minus L into Y value divided by capital Y value. What is CO? It is the optimum cycle time, which means it's the same data. Na? In the previous question, already we have calculated that as 65.71 seconds CO. L value we have already calculated as 12 seconds. Now, there is a small y there, let it be there, because this small y can be either 0.2 or it can be 0.25 or it can be 0.2, according to our example. First phase, second phase, third phase. Now, capital Y is how much? 0.65. Now, what is the challenge? Here, what value we are going to substitute? Are you going to substitute 0.2 for the first phase? This is phase 1. I'm just putting P1. This is for phase 2, P2. This is for phase 3. Now, are you going to substitute 0.2 of phase 1 or 0.25 of second phase or 0.2 of third phase? This is the only value which is going to change now. All other values are constant for a cycle. Now here, whatever phase they are asking in the question, look at the question properly. Effective green time of the second phase, which means they are asking you for the second phase. Second phase, how much will be the effective green time? Then what value we are going to substitute there? Here, what value we are going to substitute? Yes, there you go. 0.25 you need to substitute. Understood? Then you are going to get a value 20.657 seconds as the answer. Now round off to integer, so you can round off to around 21 seconds. Now suppose in the previous question, they have mentioned that round off to integer, no? So what you need to do? Finally, we need to substitute it as some 66 seconds like that. You can also substitute 65. Okay, they will give mark to both, some 65 to 66. Like that only, they may be giving you the range. Okay, but if you are calculating, like this, then here don't take 66, 65 like that. If you are getting some decimal in the calculation of CO, then use that decimal also like this. Okay, so that more accurate value you are going to get. Understood, guys? Suppose in this question, instead of asking for the second phase, they were asking you for the first phase, how much is effective green time? Then for the first phase, what will be the answer then? For the first phase, effective green time, I'm just keeping it as G effective, okay? Effective green time will be 65.71 minus 12, that is constant value, into something divided by 0.65. So till here it is same. Now, if you want for second phase, first phase, right? Second phase already we have calculated. So for the first phase, if you need what to substitute? Y1, you need to substitute 0.2. And whatever you are getting, that will be the effective green time for the first phase. If you want to calculate for third phase, then again same step, 65.71 minus 12 into for third phase also it is 0.2, na? Same as first phase. So 0.2 by 0.65, which means for the first phase and third phase, effective green time will be same. For second phase, it is going to be slightly higher. So effective green time can be calculated whatever be the number of phases. If you are having 3 phases, then 3 separate values we can calculate. If the, suppose for the, this question may be, that will be the second question which we have done. Here, how many phases are there? 2 phases are there. So how many effective green time we can calculate? 2 effective green time we can calculate. Right. So if I am asking you another question, can you solve it? Okay, can you solve it? If, okay, you want to I need the value of effective green time of first phase. I need to calculate the effective green time of the first phase. Then what to do? We know the equation C naught minus L into, if it is first phase, I can keep Y1 by capital Y. Right or not? So CO we have calculated here as 60.87. Okay, so in this question actually they have mentioned that round off to 1 decimal, so final answer you have to keep like 60.8 or 60.9. That's it. Okay, because round off to 1 decimal they told. So 8 or 9. Okay, so like that you keep. Now 60.87 minus how much was L? We have already calculated here. Second question. So 6 seconds. You know? Then how much is for the first phase? How much is Y1? That is 0.37. You know? Divided by capital Y was 0.77. Understood? So you calculate this. That will be your effective green time. That you can calculate. Suppose if they were calculating the if they were asking the effective green time for second phase, then what change is going to happen? What change is going to happen? Instead of this 0.37, we'll be having 0.4 here, right? 0.4 by 0.77. All remaining values are same. 60.87 minus 6 into 0. Okay, so this is the effective green time for the second phase. So like that, always they will mention for which phase you need to calculate the effective green time. Understood, guys? So we have discussed too many things in this session. The calculation of optimum cycle time, the calculation of capital L value separately they can ask, okay, by giving the phase as well as by giving the all run time. Then we can use this equation. What is the meaning of this critical flow ratio? Okay, the critical flow ratio will be always less than 1. That also can be a question. Okay, for 1 mark. Always saturation flow will be greater than normal flow, so that it's always going to be less than 1. Similarly, all these critical ratio which are less than 1, if you are adding, then you are getting capital Y. No, this capital Y also will be always less than 1. That's it. So both these small y and capital Y will be less than 1. That also can be asked sometimes. Okay, so these are the points that you need to keep in mind. I hope you understood the concept of Webster's method and you are getting the confidence to attend and crack all the questions which are coming from this Webster's method. So thanks for watching. Show and comment your feedbacks in the comment section if you like the video. Thank you so much. Bye.